The female engineer aged 22 to 25 quietly checks the sensors along the aircraft wing, while the workers aged 22 to 25 clean each technical compartment. In that clean and disciplined space, every system shows that future aircraft will be capable of operating automatically far more than people once imagined. The control screens continuously display algorithms that predict weather, optimize fuel, and calculate thousands of risk possibilities in only a few short seconds. When looking at that processing speed, many people begin to ask a very direct question about whether pilots will still truly be necessary in the future.
That question did not appear in science fiction imagination, but has become a real topic within modern aviation today.
Aircraft manufacturers are developing systems that can land automatically, maintain stability automatically, and adjust flight paths. Simulation tests continuously prove that computers almost never get tired and are not affected by emotions when making decisions.
That makes many people believe that the role of pilots will gradually be replaced, just like many other professions that once disappeared before the development of technology.
But right inside that maintenance hangar behind the terminal, the engineers understand very clearly that
Under normal operating conditions, a modern aircraft system works more like a coordinated network between humans and computers than a completely autonomous machine.
Every algorithm is built from experience accumulated by humans themselves.
The female engineer aged 22 to 25 checks the navigation software and understands that even artificial intelligence.
Workers aged 22 to 25 replace tiny electronic parts that many passengers will never see, but that directly affect the safety of the flight.
Future aircraft may be able to balance themselves better in turbulence and automatically analyze millions of data points while flying through the wide night sky.
Automated systems can recognize abnormal pressure faster than the human eye and can also calculate fuel-saving flight paths more efficiently than humans.
In stable conditions, pilots sometimes only play the role of supervisors instead of continuously performing direct manual operations as before.
Many modern commercial flights have used autopilot mode for most of the journey while still achieving almost absolute precision. That makes outsiders easily conclude that humans are gradually becoming a redundant link inside the cockpit of the future. But the people working inside the maintenance hangar behind the terminal understand that aviation is not built only to operate when everything is perfect. As the engineers begin to analyze more deeply, they realize that every automated system performs best under conditions that have already been predicted. The problem appears when a new situation occurs that old data has never simulated or has never been entered into the algorithm.
The Caucasian female engineer, aged 22 to 25, looks at the error report.
In the real environment, the sky never operates exactly like what has been programmed inside a cold simulation room.
An unusual forming storm, a rare interference signal, or a chain of cascading failures.
A computer can calculate extremely fast, but it depends absolutely on the data it believes to be accurate. If the input data is wrong, the higher the processing speed, the faster the wrong decision can sometimes spread through the entire system. That is the moment when the human role begins to appear, not as an ordinary operator, but as the final thinking layer of the flight.
Pilots do not only look at numbers, but also sense abnormalities from engine sound, aircraft vibration, and the unusual behavior of the system.
The ability to combine experience, intuition, and situational awareness creates the difference between a mechanical reaction and a life-critical decision. The African-American male engineer, aged 25 to 30, reopens old accident records and realizes that many of the greatest incidents in many emergency situations, the computer still continues to follow the algorithm correctly, while the outside reality has completely changed in only a few short seconds.
At that moment, the pilot is no longer someone who follows procedures, but becomes the person who must make decisions among things that have never been in the manual.
The female engineer aged 22 to 25 understands that humans can adapt to ambiguity in a way computers still find very limited. Humans can recognize that a signal is correct in terms of data, but wrong in the real context happening before their eyes.
A pilot can break from a procedure if they feel that the current situation requires a different choice to save the entire flight. That is the kind of decision based on integrated awareness that automated systems find very difficult to fully recreate through algorithms. Workers aged 22 to 25 continue checking every wire beneath the electronic compartment and understand that every modern system ports. The future of aviation, therefore, is not moving toward eliminating pilots, but toward shifting their role from manual operators.
Pilots of the future will have to understand technology more deeply, but at the same time still maintain the ability to make independent decisions when technology reaches its limits.
The greatest contradiction of modern aviation is that the stronger automation becomes, the more important the need becomes for humans skilled enough to handle the abnormal. If we only look at normal operating ability, computers are clearly superior to humans in speed and stability. But if we look at the ability to handle something that has never happened before, humans still hold an advantage that technology cannot completely replace. The aircraft system is like an experienced surgeon. Machines support a great deal, but the final decision still needs humans.
Rapes. The female engineer aged 22 to 25 analyzes emergency flights and sees that many successful situations came from...
Computers always search for the optimal solution based on data, while humans sometimes find an escape through flexibility beyond prediction. That is the difference between a system that only responds according to probability and a brain capable of understanding context through survival intuition. In the future, the cockpit may require fewer manual operations, but the psychological pressure and thinking responsibility of pilots will become much greater. Pilots will not only be people who control the yoke, but will become supervisors of every important decision made by artificial intelligence throughout the flight. The engineers inside the maintenance hangar behind the terminal understand that the stronger technology becomes, the more dangerous hidden errors become when the system misunderstands reality.
Workers aged 22 to 25 close the final technical compartment before the aircraft leaves the hangar and realize that the entire
future aircraft may become much smarter, but the true intelligence of aviation still lies in the human ability to understand what the system has not yet understood.
Pilots still matter not because they operate faster than computers, but because they can make decisions when all data begins to become unreliable.
In an increasingly automated world, the greatest value of humans no longer lies in mechanical strength, but in the ability to perceive and take responsibility before the unknown.
The future of aviation will not be a battle between humans and machines, but a coordination within the correct limits of both.
Aviation has always understood that a perfect system is not a system that does not need humans, but a system that knows when it must let humans intervene.
And that is also why, no matter how intelligent future aircraft become, pilots will always remain an irreplaceable part of the most important moments in the sky.